everyone, my name is Sumedha and in this chapter we'll study mechanical properties of the fluid. In the previous chapter we have studied mechanical properties of solid. So let us start from fluid and a very basic term, pressure. So the concept of pressure is smaller the area on which the force acts, greater is the impact. एग्जाम्पल से देखते हैं. फॉर एग्जाम्पल मेरे पास एक निडल है और अगर मैं निडल को प्रेस करती हूँ अपने हाथ पे विथ सेम प्रेशर और एक तरफ मैं प्रेस कर रही हूँ उसे मार्कर को अपने हैंड पे विथ सेम प्रेशर, तो जो फोर्स होगा उसका प्रेशर और उसका जो फोर्स होगा निडल का वो ज़्यादा होगा एज कम्पेयर टू मार्कर. सो दिस स्टेट्स दैट स्मॉलर द एरिया ऑन विच फोर्स एक्ट्स, greater is the impact. In case of needle or in case of say pen, निडल के केस में एरिया स्मॉल होगा तो इसलिए उसका जो फोर्स लगेगी उसका इम्पैक्ट भी ज़्यादा होगा. एंड अगर हम पेन को विथ सेम प्रेशर अपने हाथ पे एक्सर्ट करेंगे तो पेन का एरिया ज़्यादा है तो फोर्स क्या होगा, कम होगा. तो इसका इम्पैक्ट विल बी मोर एज कंपेयर टू इम्पैक्ट ऑफ पेन. सो दिस इज अ कंसेप्ट ऑफ प्रेशर एज वी आर टॉकिंग इन टर्म्स ऑफ फ्लूइड्स. तो एक और एग्जाम्पल कंसिडर करते हैं और प्रेशर को समझते हैं कि क्या होता है. हमने एक बीकर ले लिया, उसके अंदर फ्लूइड डाल दिया एंड एक ऑब्जेक्ट उसमें पुट कर दिया. तो ये बीकर है, दिस इज फुल ऑफ फ्लूइड. तो अब जो फ्लूइड है वो बीकर पे कुछ फोर्स लगा रहा है. दैट फोर्स इज परपेंडिकुलर टू द सरफेस ऑफ द क्यूब और एनी ऑब्जेक्ट. अब दिस फोर्स इज ऑलवेज परपेंडिकुलर to the surface of object. बीकर में फ्लूइड लिया है तो फ्लूइड क्या है, रेस्ट पे है. फ्लूइड इज एट रेस्ट. नाउ फर्स्ट क्वेश्चन, फ्लूइड रेस्ट पे है, ऑब्जेक्ट बीकर में प्लेस्ड है. हमने कहा that force is always perpendicular to the surface of object. अब जो force होती है वो perpendicular होती है, उसका parallel component नहीं होता. No parallel force. अब force के तो दोनों components होने चाहिए, तो parallel component force का क्यों नहीं act करता. Now consider a situation, अगर हम बोले कि parallel component force का act कर रहा है, अगर parallel component act करेगा तो उसकी डायरेक्शन पैरेलल टू द ऑब्जेक्ट होगी. अब जब फ्लूइड ऑब्जेक्ट पे पैरेलली फोर्स लगाएगा तो ऑब्जेक्ट भी फ्लूइड पे पैरेलली फोर्स लगाएगा ड्यू टू न्यूटन्स थर्ड लॉ. जब ऑब्जेक्ट फ्लूइड पे पैरेलल फोर्स लगाएगा तो फ्लूइड पे फोर्स लगी तो फ्लूइड का क्या होगा, मोशन होगा. फ्लूइड मोशन में आएगा एंड फ्लूइड विल स्टार्ट मूविंग एंड दिस इज अ कॉन्ट्रडिक्शन दैट फ्लूइड इज एट रेस्ट. So this is the reason why we always say that force acts perpendicular to the surface of the object. So now, how to measure force acting on the object by the fluid? So again we'll consider a beaker filled with liquid. And we have an instrument which is of the shape like this, and there is a spring inside it, and here it's a piston. Now the fluid will exert force onto this. Fluid will exert force on piston. जब फ्लूइड जब फ्लूइड इस पे फोर्स एक्सर्ट करेगा तो जो स्प्रिंग है उसकी लेंथ चेंज होगी क्योंकि फोर्स लग रही है। जब स्प्रिंग की लेंथ चेंज होगी तो स्प्रिंग भी फ्लूइड पे ऑपोजिट फोर्स लगाएगा ड्यू टू न्यूटन्स थर्ड लॉ। तो जो फोर्स स्प्रिंग लगाएगा लिक्विड पे फ्लूइड पे एंड जो फोर्स फ्लूइड लगा रहा है इस सिस्टम पे दैट विल बी इक्वल। सो फ्रॉम दिस फ्रॉम द फोर्स or from the force of spring we can calculate the force which is exerted by the fluid. Now हमें force पता चल गई है। say this is of area A, तो pressure कैसे define होगा? pressure is equals to force upon area, or we say delta F upon delta A because we have considered a very small area. Now, if we consider this is very small and delta A approaches to 0, limit delta A approaches to 0, that means area element approaches to 0, then we'll get pressure is equals to force upon area. So this is the formula for pressure. अगर यूनिट्स देखते हैं तो अगेन फोर्स इज इन न्यूटन, एरिया इज इन मीटर स्क्वायर, सो वी हैव न्यूटन मीटर -2 और वी हैव पास्कल. So these are the units of pressure. Now let's discuss 1 atmosphere of pressure. This is also a very common unit for the pressure. So 1 atmosphere is equals to 1.013 10 to the power 5 Pascal. So this is the pressure exerted by the atmosphere at the sea level. So now let's talk about density. Density is mass upon volume. For example, density of a water at 4 degrees Celsius is 1.0 into 10 raised to power 3 kg meter minus cube. So the units are from mass is in kg and volume meter cube. So this is the density of water. We can also calculate relative density. This is calculated density of the object given, density of the material or object upon density of water. For example, we have aluminium and its density is 2.7 into 10 raised to power 3 kg meter minus cube. And we have to find relative density of aluminium. So it will be given by relative density 2.7 into 10 raised to power 3 kg meter minus cube divided by density of water, which is 1 into 10 raised to power 3 kg meter minus cube. So this cancels and we get the relative density as 2.7, and density is denoted by rho. So this is about density and atmospheric pressure. So now we'll study Pascal law. So let's study from the diagram. We have taken a container in which this pyramid-like structure is placed. This is side AB, BC and DF. So this is in fluid. तो fluid force exert कर रहा है हर face पे. The force exerted by the fluid at this face is FA, at this face is FC and at FB. So we have forces FA, FB एंड FC। तो अब फोर्स एक्सर्ट हो रही है, इस एलिमेंट का कुछ एरिया होगा, सो द कॉरेस्पॉन्डिंग प्रेशर टू द फोर्सेस आर PA, PB एंड PC। दैट मीन्स इस फेस पे प्रेशर PC है, इस पे प्रेशर PB है एंड इस पे प्रेशर PA है। So now by equilibrium we can say that sin theta is equals to FC upon FB and cos theta is equals to FA upon FB. So we can write FC is equals to FB sin theta and FA is equals to FB cos theta. Say equation 1. We get this by equilibrium. And next equation by geometry, so now by geometry we can see sin theta is equals to AC upon AB and cos theta is equals to AA upon AB, or we can write AC as AB sin theta and AA as AB cos theta. This is equation 2, where A is the area element of this side and this side. So now from 1 and 2 we can conclude FA upon AA is equals to FB upon AB is equals to FC upon AC, which is equals to pressure at A is equals to pressure at B is equals to pressure at C. So this states that pressure is equal at all different points. So pressure is equal at all these points, or we can state that pressure is same when fluid is at rest. So this is a Pascal's law. So now we'll study variation of pressure with depth. For that we have again consider a container जिसमें fluid है and एक cylindrical object है. So pressure P1 is exerted on upwards and pressure P2 from downwards. So let us write force vertical upwards, that is P2A, and force vertical which is acting downwards is P1A. Say equation number 1. अब ये थी vertical forces की बात, but horizontal forces जो लग रही है they are cancelling each other. Horizontal forces cancels. From the diagram you can see ये forces एक दूसरे को cancel कर देंगे. So we have this equation. Now from both the forces the mass of this object is maintained. So let us consider, let mass be m. So for equilibrium, or when the mass of the body is maintained by the pressures, we have P2A minus P1A is equals to mg, where this is also force, this is also force, and mg is also force which is acting by gravity. So we can write it as P2 minus P1 into A is equals to mg. Say equation 2. Now from the definition of density, from definition of density. We have density as mass upon volume. So we can write mass as density into volume. So substituting this value into equation 2, we'll get P2 minus P1 into A as rho Vg. So we get this. Now volume. We can write volume as area element into height of the object, where height is h. Substituting the value of volume, we'll get P2 minus P1 into A rho A H G, and A cancels out, and we finally get P2 minus P1 as rho G H. So now this result shows that the difference in the pressure at different point is related to height h. Now we consider pressure P1 as atmospheric pressure. That means जब ये pressure है, ये object पे act कर रहा है where the water level or the fluid level is up to this mark only. तो जो अब यहाँ पे pressure act होगा, that will be atmospheric pressure. So we'll say P1 as PA, and we'll replace P2 just by P. So substituting these value into this equation, we'll get P minus PA is equals to rho G H, or pressure is equals to PA plus rho G H. So what this equation states that the pressure exerted at some depth of h is greater than atmospheric pressure by the value of rho G H. So this is the variation of pressure with depth. So now let's start a numerical problem. What is the pressure on a swimmer 10 meter below the surface of a lake? So we have to calculate pressure. So pressure is equals to pressure due to atmosphere plus rho G H. This is the formula for the pressure at some depth. So here height is given 10 meter. So substituting the value, PA is the atmospheric pressure, which has value 1.01 into 10 raised to power 5, plus rho is the density of the water, because we have talked about lake, so it's very obvious it's the density of the water, which is 1000 kg minus cube, and this is Pascal, into G, gravity. For our simplification, we will take 10 value of G, and height is given 10 meter. So on calculating this, we'll get 2.0 into 10 raised to power 5 Pascal, or we can write pressure as 2 atmosphere. So this is the pressure which the swimmer will feel when it is at a depth of 10 meter. Now we'll study Pascal law for transmission of fluids and how this law helps us. So Pascal law for fluids or transmission of fluids states that whenever external pressure is applied on any part of a fluid container in a vessel, it is transmitted undiminished and equally in all direction. That means जब कोई एक्सटर्नल प्रेशर हम अप्लाई कर रहे हैं तो वो वेसल में फ्लूइड से ट्रांसमिट होगा एंड इट विल बी ट्रांसमिटेड अनडिमिनिश्ड विदाउट एनी चेंज एंड इन इक्वल इन ऑल डायरेक्शंस. सो ये दो पॉइंट्स को देखते हुए we'll study application, and application is hydraulic lift, and we'll study how hydraulic lifts work. So we have a container, and this is say 1 and 2. So at 1 we have a surface of area A1 where area A1 is less than of area A2, where area A2 is the area at second. So we'll apply force F1 on this area A1, and on applying this force the pressure is transmitted through this liquid, and here the second platform will experience pressure and force, due to which we can lift any object on this platform. So from the definition we have pressure 1 F1 upon A1 equation number 1 and pressure at second F2 upon A2 equation number 2. Now we state external pressure is transmitted undiminished and equal in all direction. Therefore pressure 1 is equals to pressure 2. So we get F1 upon A1 is equals to F2 upon A2. From here we can calculate force on the second, which is F1 A2 upon A1, where A2 upon A1 is the mechanical advantage. That is, by changing force on A1, we can move up or down platform 2. So this is the application of hydraulic lift. We'll see you in the next video. Till then, keep revising.